Hello, my fellow gnomes. Welcome to another video. So today we're going to be talking about exploiting. And to do this, I've got this example project I've set up called the Labyrinth. And in the Labyrinth, we've got zombies and we've got gold coins. It's a pretty simple game. We've got a bunch of server scripts going on, and we've got some weapons that people can buy. And then we've got remote events and a bunch of stuff for the client. Now, most players are going to have a great time in this game, but of course, not everyone is going to play by the rules. So right down here, we have got Billy McMischief. And as we can tell from his mask and his bright green hair, he is only here to cause trouble. So what can Billy get up to? Well, he can actually look into the workspace, see everything in there, and see everything in the player scripts, his GUI, and replicated storage. Now, he can't view anything in the server storage, as we can see. He can't see the server script, but he can see all of these local scripts. Now, you may think, well, he can't do anything, right? Everything is on the server. But here's the crucial thing. It's how the server communicates back with the client. So Billy has a snoop around, and he sees in the shop there's this RPG for 100 gold coins, and he'd really like it, but if he keeps clicking the button, nothing's going to happen. He wants to know how it works. So the first thing he notices is this buy item remote event in replicated storage. And then he looks inside the shop script, and he sees, there it is, on line 14, they're using the buy item remote event, and they're telling the server they want to buy this item for this much money. Now, this check to see if he can afford it is happening on the local script, so on the client, not on the server. So what Billy does is he simply copies this line and he executes a piece of code himself. So if we were to go and add in a local script into replicated first, for example, and we can start typing a script and run it while the game is running. Now, this might seem a little bit odd, but this is essentially what executors, you might have heard of like Synapse or Scriptware, Kernel, a few of the applications that people use. This is essentially what it allows them to do. So if he could type in RPG, and then he could type in a price, he hasn't got any gold at all, so he's just going to put a 0. And if we do Control X and Control V, the script will run. And suddenly, Billy has himself an RPG for absolutely free. And now he's figured out that he can manipulate the remote events. He can get up to even more trouble. Unfazed, he goes back to his script, and instead of entering 0 for the amount, he tries to enter minus. And he enters minus 10,000 or whatever that is. Runs his code, and suddenly he has 2 RPGs, and now he has 10,000 gold in the game. So he's found the way to give himself infinite items and infinite money. Oh dear, Billy McMischief. What a lot of trouble you are. So how can we stop him getting up to his antics? So if we hit stop, and what we're going to do is we're going to head into our shop server script. Now, the first thing we want to do is we don't want to trust anything that comes from the client. So any remote event like this that's being triggered by the client, whatever parameters they send, we want to assume is complete garbage, right? We don't want to trust anything. So instead of taking the price they say it is, we're not going to be interested in that anymore. Instead, we need to have a list of prices on the server. So if I create a item prices table like so, I can now authoritatively say that a sword costs 10 gold, a pistol costs 50, and RPG costs 100, and Billy isn't able to tamper with it. And then all I need to do is I need to have a little if statement down here so we can check if the value of the player's gold, if that is greater or equal than, and we'll check the item prices table, and then we will use the item name. Then we can start taking away his money and giving him the item. Okay, so exact same setup before, but this time if I try to execute this code, absolutely nothing is going to happen. So Billy, no luck there. So now that our remote events are secure, our game is fine now, right? Our hackers can't do anything. Well, there's another big room for exploits, and that's to do with network ownership. So what I'm going to do is I'm going to go to Studio Settings, and I'm going to turn on these two visualizations just so we can see what's happening. And now when I click play, we've got this big green cylinder around my player and this green box. And this shows me what I have network ownership over. So currently it's just my player, which means that the server sort of trusts me to tell it where I'm going, which makes it a bit more responsive. If the server was telling me where I could go, then I'd have to wait to send messages back and forth all the time, and there'd be loads of movement delay. Now you can see this sphere keeps growing over time because there's no more players in the game. So it's going to keep growing until it gets bigger and bigger and bigger. And as things enter my sphere, you see these objects that are, at the moment, they're marked white. But as they enter my range, they're going to turn green as I gain control of them. Now this means I can start to do some interesting things. So all of these zombies that are moving around the map, I can now tell the server, right, I want this zombie to go over here. And I can start moving their positions and just have them all fall off the map. And in fact, now my sphere of influence covers nearly the whole game. I could just move all of them all at once, off they go, all off the map. And those changes are actually going to take effect on the server. So we can see we're back on the server now, and all the zombies have disappeared. Oh dear, that's not very good at all. So how can we stop that? Well, it's really easy actually. All we have to do is go into our game script, and where we add in our zombies to the game, immediately after we've parented them in, we can just say zombie.primary part, and we use the function setNetworkOwner. And we're going to set it to nil, which means that the server always has ownership. We will never give it to a player. And we're going to do the same function for our gold coins as well. So if we say gold, and we'll set that to the server. So now when Billy plays the game, his network ownership circle is still going to grow. But when it gets big enough to cover these zombies, he's not actually going to be able to move them. Let's see. So if I move towards these zombies, they're now in my range and they're still white. And if I was to click them and start dragging them about, you'll notice they just snap back immediately. I don't actually have control of them. I can't tell them where to go. And I'm actually just going to get killed by the zombie. Oh dear. Now, by the same token, I can't move the coins either. So if I see one of these coins and I move it towards me over here, and I put it right behind me. Oh, and a zombie's coming after me again. But if I've got this coin and we go back on the server, we'll see it's not actually there. I might have moved it towards me on the client, but it's not really there on the server. However, if I'm then to touch the gold coin, watch what happens. Oh, the pickup actually works and I have 1 gold. So this is all to do with how collisions are handled. You might expect that the touched event is server authoritative, since it's in a server script. But Roblox actually gives the players quite a bit of flexibility, and the players are able to fire their own touch collisions. So in order to check that the player is actually within proper range, we can just do a quick distance check. So how we'll do this is we'll say local distance equals, and we can say the player.character.primaryPart.position. And we're going to take that away from the position of the gold.position. And then what we do is we get the dot magnitude of both of these. So that's essentially the difference between these two. That tells us how far away they are. And if that distance is, say, less than 5 studs, then it's safe to assume they're within range and we'll actually let them have that gold. So Billy Mischief, he's back at it again, and he clicks one of these balls and he moves them all towards him. He starts stockpiling them all, Let's see, there's a few more over there. Grab all of these. And of course, if we're back on the server, we see there aren't any here at all, but Billy thinks that he's got them. But if Billy goes to touch them, well, nothing happens because he's not actually within range of them. So he can't pick them up because we got that magnitude check. Now, if he goes to where the coins actually are, so to say there's one over here, look. And if he goes over there to where it used to be, or where the server thinks it is, he can actually fire that event. So there we go. He's got 1 gold and it's working properly. So he can't touch the ones that he faked, but the ones where they are where they're supposed to be, he can actually touch them. Now, dealing with exploiters is always a bit of an arm race, and this time it's no exception because Billy has come back yet again, and this time he's brought along his little commands, and he's got a little speed hack that he decides to use. So he puts in speed 50, and now suddenly has a walk speed of 50. He could go even higher if he wants, if he goes all the way up to 100, and now he can zoom him out the map, and he can collect all these coins in their proper position. And he doesn't really have to worry about the zombies or the coins because he can just move his character where he likes. So how could we go about combating this speed hack? Well, to do that, we're going to need a server-side check. So we're going to have a new script, and we'll call this anti-exploit. And we're going to check every single player in the game. So we're going to need the player's service. And then we'll check for when a player is added. And then when their character loads in. And I'm also going to throw in an extra cheeky little wait, because sometimes I find that all the parts aren't properly added when the character added is fire. So we've got in a little extra wait of a frame. And then we're going to get that root part. So local root equals, and we're going to get their current position. So now we've saved that to a variable, which means we can use it along with the time that they were at this position. So now as the character moves and their position changes, we want to keep checking how far it has moved from the last position. So we're going to use a while loop, and we'll keep repeating for as long as the character has a parent. And maybe we'll have a delay of half a second. We don't really need to check this every single frame. Half a second is probably fine. So the first thing we'll do is we'll calculate how much time has taken place. So time taken to move is simply going to be equal to tick, the current time, minus that last time variable we've saved. So it should be about half a second, but this will allow us to get it a bit more precise. Next up, we want to know how far they've moved. So local distance moved is going to be equal to their last position, take away from their current position, and then we'll get the magnitude of that. And then what speed they went, well, speed is simply equal to distance over time. So distance moved divided by time taken. Now, bearing in mind that a standard humanoid character walks at a max speed of 16 studs, we're going to create a variable at the top, and we'll say local max speed. We're going to set this to 25, which is generous, but it gives a little bit of leeway. So we will see if that speed is greater than the max speed, then they're probably cheating. So we can print out cheat, exclamation mark. And then once we've done that, we just need to set the new position. So last position is now going to be back to the root.position. And last time we're going to set to the latest tick. So let's turn on our output so we can see what's happening. So there we go. We've got nothing in the output. We're moving normally. But if we add our speed hack again of 50 studs, suddenly we get cheat that starts appearing in the output. Oh dear, Billy McMischief, we've caught you. Now, there is one slight problem with this script, and with any anti-exploit script, in fact, which is that we have to make certain assumptions about the game. So, as well as just printing out cheat, let's print out the actual speed, so we know how fast they're going. Now, it might seem great to account for up to 25 studs, but there's one problem with this. So we can see normally, yeah, we're just 16 if we're walking about, but if we've got jumping in our game, say, well, look, I've suddenly managed to get up to some quite high speeds with jumping. I'm going up to 20, and if I jump down and I fall, I can get 36 studs. So if I've got a lot of jumping and falling in my game, then this is going to cause me quite a lot of problems. And then, of course, if Billy starts doing something like he decides to start flying, well, then I'm going to be up at some really high speeds, and it doesn't really matter at all then. So how could we counteract thinking of airtime, thinking of flying? How can we stop Billy from doing this? So the first thing I'm going to do is I'm going to go and create a new function. And this function we're going to call the touching floor function, okay? And we'll send the root part to it. And what we're going to do in here is we're going to raycast to the floor from the root part. If you're not familiar with raycasting, I'd recommend checking out my video. I have a tutorial on that. But we're going to go ahead and create our raycast here. So first up, we'll create some parameters because we don't want the raycast to come out of our root part and immediately hit our own legs. So we want to be able to filter that out. So we use a blacklist, and then what we're going to add onto the blacklist is our own character. So that'll be root.parent. And then we can now construct our raycast using the workspace raycast function. The origin is simply going to be the position of the root. And then the direction, well, we can just create a very simple one. We want to go straight down. Now, a standard character, their legs are 2 studs high, and the root part is 2 studs high as well. So if we're in the middle and we go down 3, we should hit the floor. So -3 will do the job. But we'll add on an extra half stud as well, just to give us a little bit of leeway. And then 0 on the Z. And then finally the params as the third argument. We do actually want to do this raycast multiple times. We don't want to do it just once, because if they're standing slightly on the edge of something, it's possible they could stand with their left leg, but the middle of their character would actually, the raycast would fire to the ground. So we're going to create a variable called x. And initially we'll set it to -1. And then we're going to do 3 different raycasts. So for I equals 1, 3, do, or even we can actually just say for x equals -1, 2, do, or 1 rather. So you want -1, 0, and 1. Yeah, why use 2 variables when you can use 1? So great, instead of going straight to the root.position, we can say that the origin will be equal to the root.position plus a new position, vector3.new, and we're going to say use that x value. So now we can construct our raycast within the loop using this new origin value. And then if we have a successful raycast and that raycast hit an instance, a part, then we know that we're touching the floor. So let's have a local touching floor, or we could say is touching floor, and then we'll set that equal to true. Otherwise, it's going to have its default value of false. And then at the very end, we can simply return whatever the value of is touching floor is. So now we just need to call this function. So we're going to go down here, and instead of doing it inside of this loop, which is repeating every half a second, we probably need to be a little bit more accurate. So let's create another loop, while character.parent again, and this time we'll have it run every frame. Now obviously we can't do this because if we create a loop before another loop, then we're going to get stuck in this one, and this one will never be able to run. So let's use the task.spawn, and then we can create a function on a new thread. So then it can run this and it won't yield. It can do them both almost at the same time, essentially. So if we are touching floor, send the root, then we need to have some a last position and a last time, just like before, really. So we'll have another variable called last touched floor. Initially, that will just be tick, and then we can update it every time they touch. The last touch floor will now equal tick again. So every time we go around, we can keep updating that value. And then we probably want to check how long it's been since we've touched the floor. So local time since floor will equal to tick the current time minus that last touched floor value. And so we probably want to have a global, like for the max speed. Let's create another one called max air time. We can set this equal to 3 seconds is probably enough, assuming we're not going to have any jumping. And this is really where, if you're writing an anti-exploit script, you've got to customize it to your game. So 3 seconds is probably enough. I'm not having any obstacle courses where people can jump or fall. They're mostly just walking along. So if anyone's in the air for more than 3 seconds, so if time since floor is greater than that max air time, then we know that they're cheating. So we can print flying cheat, or else we'll just print an update of how long they've been in the air for. And let's comment out these prints from the speed cheat, and we'll just go and we'll test this out. So we're going to see a ton of stuff in the output, and these are all really small numbers. And if we jump in the air, we can see they go up ever so slightly to like 0.4 or something. But if I now turn on my speed hack and I start to... Oh, what am I trying to do with speed? Sorry, speed. Yeah, I don't want speed. We want our fly hack. So Billy turns on his fly hack and you see this number starts to go up. 1, 2, 3, and there we go. Flying cheat, we've got him. And if he comes back down again, then the count resets. And as soon as he goes back up into the air, he's a flying cheat. So now we're recognizing that, or we suspect that people are cheating. What are we actually going to do with them? Now, we could just be harsh and we could kill them. We could even kick them or ban them from our game. But arguably a better solution is just to move them back to the last good position they're in, the last proper non-cheating position. Because bear in mind, we might well have false positives with this system. So we don't want to have unfairly punish people if they're just lagging. So let's try and tie this anti-exploit system together. So we want another variable, and that's to store the last good position that we knew that the character was at. So local last good position, and we're going to set this to the root.cframe. And now we can use this, and we want to set their position to this good position when they've been cheating. Character pivot to last good position. That's all we have to say. But of course, we do have two different cheats going on. We've got this flying cheat and we've got this speed cheat. And we don't want each of these getting in each other's way. So we'll have another two variables and we'll just say local fly hacking and local speed hacking. So now we can access the state of these in both loops. Fly hacking is going to be the result of whether time since floor is greater than max airtime, and then we just say if that is true, then we will pivot them to, but else if they're not fly hacking, then we also want to check if they're not speed hacking. So if they're not speed hacking, then, and we probably want to check as to whether this is a good position to set, because we might not have hit the threshold for fly hacking yet, but if they're still in the air, we probably don't want to save this as a position. So up here, let's have another variable for local is touching floor equal to the result of this function. And then we can check it. So if not speed hacking, if is touching floor, and we probably want to know the time since floor as well. Because if it's been like over a second or something seems to touch the floor, that might be a bit suspicious. So we'll check that they have a firm grip on the floor, like lots and lots of recent touches. It's less than 0.1. And they're not speed hacking, then if it meets all of these conditions, then I think this is probably a good position. So we're going to update it. Last good position now equal to root.cframe. And then we're going to do a similar thing down for our speed hacking function. So we're going to set speed hacking equal to if speed is greater than max speed. And then if, so we change that statement around, if they are speed hacking, then we're just going to move them back. So character, pivot to last good position. And so once we have all of this set up, we can go back in and play. And hopefully we should get a feel for the restraints that are going to be replaced on us. Now, this is by no means a perfect system. With any anti-exploit system, you're always going to have some issues. But if we start flying and we go up into the air, we're going to get thrust back right into place. And so we can't get very far at all before we're immediately teleported. Now, we could probably cheat it a bit by sort of jumping onto a wall quick. But then we're not really flying. Like, the player is almost just playing normally. And of course, if they go too fast as well, then they're also going to get yanked about. Apologies if this doesn't look very good on the video. It's probably a little bit jittery watching all of this rubber banding, but we can at least see that our anti-exploit system is working. And if we turn up the speed even more, it should become even more apparent. If I try to zoom about, it's not really going to let me. It's going to keep thrusting me back to the last good position. The only way for me to get away with it is, again, if I sort of try to inch gently along. So sure, I might be using my flying and my speed cheats, but I'm significantly hampered if I am doing so. So it's probably a decent balance for a anti-cheat system. But there we go. Hopefully that's given you some ideas of how to combat stuff. You could add a lot to this. You could, a lot of tweaking to do. If you're going to add this to your game, you probably need to do a lot of testing first. I'm not going to be adding this to any of my games just yet, but I wanted to give people some ideas of ways of combating things. If you have any thoughts on this, then let me know down in the comments, and I'll see you all in the next video. Thank you very much for watching, and goodbye!